Hi, my name is Ross Smith, and I'm a program manager within the Intune Customer Experience Engineering team. And today I'm going to talk to you about how we protect Outlook data on your devices. By the end of this session, we'll cover the differences between device and app management solutions, device risk, and how that can be used to protect access to the data, and finally, methods to protect Windows and mobile devices. Historically, device management has its roots in joining PCs to a domain, and even there are historical roots embedded in Exchange with mobile messaging access, where mobile device mailbox policies push down things like encryption and PIN. But since then, device management has evolved, and now we have unified endpoint management solutions that are designed to not only protect the device, but also configure that device, whether that configuration be things around ensuring compliance or enabling or disabling certain settings within that device. And then we have other advanced configuration scenarios like pushing down profiles, whether that be certificates used for authentication or SMIME, VPNs to enable access to on-premises resources, or app management, where we can push down specific apps, configure those apps, and then ultimately remove those apps when needed. But device management is really around the entirety of the device lifecycle and ensuring that we can retire that device at the end of that lifecycle. Device management requires device enrollment. Alternatively, we have application management. Application management differs from device management in that application management is focused on the configuration and protection of the apps themselves and the data contained within them, as opposed to the end-to-end protection of the device. Application management solutions enable the capability to publish apps, to configure those apps, and ultimately remove the data from those apps. But the key difference is application management solutions don't necessarily require device enrollment. Now, you may think that device management and application management are potentially competitive solutions to one another, but that's farther from the truth. They are complementary to one another. You can have a device that is enrolled and use an application management strategy to further protect the data on that particular device. With Endpoint Manager, Intune provides the capability to enroll devices. Intune also provides an application management solution for mobile devices, which is known as App Protection Policies. App Protection Policies can be deployed on mobile devices independent of whether the device is enrolled or not. You have the flexibility with both device management and application management to deliver a solution that ensures the data on your devices are protected based on the needs of your organization. While this session won't cover how we enforce the data protection mechanisms we'll be discussing, the reality is that you do that through Azure Active Directory Conditional Access. Azure Active Directory Conditional Access is a policy-driven approach which takes a set of assignments and conditions and then makes an intelligent decision as to whether to block or allow access. From an assignment perspective, we look at who's attempting to authenticate and what resource they're attempting to authenticate against. And then we can evaluate a number of different conditions. What IP address are they using? What device platform or operating system is being used? And finally, what client apps are being used as part of this authentication request? Conditional access can also evaluate the user's risk to make a determination of whether that account is compromised or suspicious in nature. If the account's compromised, it could force a password reset. If the account's suspicious, it could force a different behavior, like blocking access outright or requiring further access requirements like multi-factor authentication. Ultimately, the set of assignments and conditions will dictate whether we allow access or we block it. With every connection attempt, we need to be assured that access to the data is protected. One way to ensure that the data is protected is by evaluating whether the device making a connection is suspicious or not. It's not simply validating whether the device is enrolled and meets a set of defined compliance policy requirements, though. We actually need to look deeper and determine whether that device has things like malicious apps or maliciously defined profiles or if that device and/or apps are performing unusual activity. In order to do that, we need an endpoint detection and response solution. So there are two forms of an endpoint defense and response solution. You could leverage a threat defense partner, or you could leverage Microsoft Defender ATP. Both can evaluate the health of a device and report a risk level back to the unified endpoint management solution, whether that be Intune or a third-party provider. That risk level can then be used as part of the compliance policy to define the state of whether the device is considered to be compliant or non-compliant. If a device is then considered to be non-compliant, the conditional access engine can block further access attempts, while the compliance policy can dictate non-compliant actions, like the blocking access to the device or removing data from the device if necessary. With threat defense partners, these are mostly focused around mobile devices. These threat defense partners have a connector that connects with Intune, and that you deploy a mobile app to the device. These threat defense partners work whether the device is enrolled or not enrolled, and are even supported with Intune app protection policies. These mobile apps can detect operating system vulnerabilities, malicious app installation, and even malicious network profile installations. The mobile apps analyze the data and report telemetry back to the threat defense partner. And that threat defense partner then ultimately makes a decision of what that risk category is for that particular device. Likewise, Microsoft Defender ATP does something similar on Windows, Mac OS, and Android devices. But let's use an example of where Defender ATP becomes useful. So let's say, as a user, I'm using Outlook on my Windows 10 device, and I receive an email from a colleague that I know very well. Within this email is an attachment. And so because I'm rather trusting of the user that sent me this, I launch that particular attachment and I remove any restrictions associated with that attachment and say maybe load the macros associated. Unfortunately, within that attachment is malicious content. And as a result of me allowing the execution of that malicious content, I have unknowingly started an elevated privilege attack on my system. And that attacker is able to then access my machine remotely with administrative rights due to an unknown Windows vulnerability. This breach enables the attacker to launch a successful attack against other devices within the organization. Defender ATP can help resolve security incidents like this. Defender ATP can detect that abnormal code was executed, that a process privilege escalation occurred, or that malicious code was injected, or that a suspicious remote shell was executed, like in this example. The combination of all of these different detection events can allow Defender ATP to assign a high risk to my particular device, which will then mark that device as non-compliant and trigger a number of non-compliant actions, including alerts to security team within the organization. Now that we can detect the risk associated with the device, let's look at how we can protect those devices themselves. And we'll start with Windows devices, focusing on both corporate-owned devices and personally owned devices. For corporate-owned devices, there are a number of things that we want to enable on those devices. We want to enable Windows Hello. Windows Hello is a form of multi-factor authentication. It replaces the standard authentication mechanism with either biometrics or a PIN, thereby enabling a situation where it's something you know, something you have, and something you are, which is a strong mechanism to protect the device while minimizing inadvertent access from unwanted attacks. Likewise, we need to create a compliance policy that enforces health attestation, like ensuring that secure boot and code integrity are enforced on that device, and configures security settings like requiring antivirus and anti-spyware, and requiring a trusted platform module, and of course, enforces encryption through BitLocker. A compliance policy is also where we define our risk score and what our non-compliant actions would be, like whether we're going to block access to the device while the device is considered to be non-compliant. We also need to deploy security baselines for Windows 10, Defender ATP, and Edge. These security baselines are developed by our engineering teams responsible for these products, so they take into account the best possible scenario to ensure the device is protected. And of course, it goes without saying that in order to protect Outlook data on a Windows device, we need to have BitLocker deployed and configured. So we need to create a disk encryption policy for BitLocker that defines settings like what disks we're going to encrypt, what recovery mechanisms we're going to use and support. And then finally, we need to ensure that updates are deployed automatically, not only for Windows 10, but for Office, because by ensuring that monthly security patches are deployed, we're guaranteed that our devices are at their most protected state. But what about unmanaged Windows devices, those that are personally owned? Do we allow access? That is a question that as an organization, you'll need to be able to answer. You may choose not to allow access at all, but if you want to allow access, you can do so with Outlook on the web. Outlook on the web supports a conditional access session control known as app enforcement restrictions. When app enforcement restrictions is configured appropriately, both within conditional access and through the OA mailbox policy conditional access policy parameter, Outlook on the web will not allow users to print or download attachments on devices that are not enrolled in a unified endpoint management solution. This will ensure that when the user logs off the session, that no data is retained within the session cache, thereby minimizing any potential data leakage that an attachment would otherwise leave behind. So now that we've discussed how to protect Windows devices, let's look at how we can protect mobile devices. With mobile, we have both iOS and Android. Both platforms provide their own unique ways to manage the devices. On iOS, device management depends on whether the device is personally owned or owned by the organization. For personally owned devices, organizations can choose to whether to allow device enrollment or user enrollment. The difference primarily being in the level of control that the organization has with device enrollment compared to user enrollment. When the device is managed, the company portal app is used to push and deploy apps and the app configuration. For corporate-owned devices, organizations have the choice of deploying what's known as supervised mode. This is an enhanced level of configuration on the device that provides further lockdown on what the user can end up doing with that particular device. Organizations also have the capability to utilize solutions like Volume Purchase Program for app management and deployment. And of course, it goes without saying that device management is not necessarily needed either, as you could leverage an application management solution like Intune app protection policies to protect data at the app layer. Likewise, Android offers a very similar deployment model. Android Enterprise offers a number of different models in which you can manage the device. If the device is personally owned, Android Enterprise offers the concept of work profile. What this means is that when the device is enrolled, two profiles are instantiated on the device, one for personal use and one for work use. The work profile is managed by the organization and utilizes Manage Google Play. The administrator can push down certain apps into the work profile. Likewise, the user can install only apps that have been approved by the organization. For corporate-owned devices, there are a number of different models in which you can manage the device, and I highlight two on this slide. You have Android Enterprise Fully Managed, which, as its name implies, manages the entirety of the device and enables or disables certain feature sets appropriately per the organization's requirements, and leverages Manage Google Play for app deployment and management. And then there's also Android Enterprise Dedicated. With Android Enterprise Dedicated, the device is locked down to only allow one or more particular apps to be launched. This dedicated mode is really geared around kiosk-based scenarios where you may have, say, a line of business app that you want to only be used on that particular device. And just like with iOS, we don't necessarily need to enroll the device to get protection. We could leverage Intune app protection policies to manage the data at the app layer itself. Now, what are app protection policies? App protection policies are based on the identity. We know users have multiple accounts on devices they bring to work. They have their personal identities and they have their work identities. And in fact, all of the Microsoft mobile apps are multi-identity aware. That enables users to have an experience that matches their day-to-day life. As an example, the ability for me within Outlook for iOS and Android to see my entire calendar from a time management perspective. So I know what I should be doing from a work perspective as well as from a personal perspective. The policy settings within an app protection policy can be broken down across three key verticals: conditional launch, access requirements, and data protection. Conditional launch allows us to evaluate the health of the device. And that's important because we may not be enrolling that particular device. We can evaluate whether that device is jailbroken, rooted. We can leverage a mobile threat defense partner to assign device risk. We can look at characteristics of the operating system, like its version. We can evaluate the Android patch level. We can look at the device model or manufacturer. The end result being that as an administrator, you'll have the capability to target different settings and define behavior as a result of when that app launches. For example, if the user has jailbroken their device, you can assign a conditional launch policy that detects that and wipes all the work or school account data within the apps, leaving the personal data unaffected. Or in the case of an operating system version, you could assign a policy that warns the user in the event that they aren't using a supported operating system version. Likewise, if you're an organization that wants to manage which particular device models can be used to access work or school account data, you could have a policy that blocks certain device models from being able to access work or school account data. From an access requirement perspective, because we're not relying on the device being enrolled, we need to ensure that access is protected because a device PIN may or may not exist. And if that device PIN does exist, it may not be strong. So with access requirements, we can assign a PIN to access the work or school account data within the apps themselves. That could be a simple or complex PIN. It can support biometrics, or it could utilize the user's Azure Active Directory credentials. And like with any sort of access requirement, there are inactivity timers that define how often the user must provide that PIN or biometric to access the work or school account data when the app is brought back into the foreground. Likewise, these inactivity timers can block access or wipe the work or school account data in the event that the app itself hasn't connected to the Intune service after a period of time. And then from a data protection perspective, we once again need to ensure that the data is encrypted within the apps because we cannot be reliant on the device being enrolled. This leverages algorithms within the Intune SDK to encrypt that data. But we don't stop there from a data protection perspective because we've also introduced data transfer mechanisms to protect the data by ensuring that data cannot be transferred to personal apps or apps that aren't protected by an app protection policy. We can even do this granularly with web links, such that when you access a web link within your work or school account, we can force that that web link must be opened within a protected browser like Edge for iOS and Android. And then finally, as an administrator, I have the capability to initiate a selective remote wipe of the work or school account data. Again, ensuring that the personal data is left behind in the event that that wipe is completed. You may be wondering what settings within the app protection policy you should deploy for your organization. The good news is that we recently launched our App Protection Policy Data Protection Framework, which will help organizations like yours to identify the appropriate settings that they should deploy. And we've broken this data protection framework into 3 distinct configuration levels: basic data protection, enhanced data protection, and high data protection. Our basic data protection configuration level is an entry configuration that is very similar to what you offer today with an Exchange Online mobile device mailbox policy. It enforces a PIN and encrypts your work or school account data. But unlike the mobile device mailbox policy within Exchange, this policy applies to all of the Microsoft mobile apps, thereby ensuring your data is protected whether you're accessing email or OneDrive for Business, or you leveraging Teams to establish a call. This configuration level also introduces many of the conditional launch behaviors that I have previously discussed, and includes things like ensuring device attestation with Android and Google Play Protect. Our enhanced data protection configuration level includes everything in level 1 and introduces our data transfer mechanisms to minimize data leakage events. It also enforces a minimum operating system requirements. We believe the enhanced data protection configuration level is applicable to the majority of your users accessing work or school account data. And then finally, we have our high data protection configuration level. This configuration level is desirable for users that access highly sensitive information, that are high risk themselves, or potentially regulated. It includes everything in level 2 and applies advanced data protection mechanisms, like requiring a protected dialer, introduces enhanced PIN configuration, and requires a mobile threat defense partner. To deploy the App Protection Policy Data Protection Framework, you can import our JSON templates with Intune PowerShell scripts and then assign these policies to users. Now, the good news is that this is simply a framework. It defines various settings we believe you should deploy, but you can customize the data protection framework however you see fit to meet the needs of your organization. Now that we understand what app protection policies are, let's do a demo. To start, let's review our app protection policies. In this tenant, we have 2 app protection policies, one for iOS and one for Android. Both are configured with the enhanced data protection configuration level as defined in the App Protection Policy Data Protection Framework. Let's look at the iOS policy. In this policy, we can immediately see that a number of apps are targeted, including Outlook, Edge, OneNote, and others. Now let's look at the data protection settings. For the purposes of this demo, I'll focus on 2 specific settings. First, let's look at the restrict, cut, copy, and paste between other apps. This policy setting is configured with a value of policy managed apps with paste in. Now, what is the definition of a managed app? A managed app is an app that contains a work or school account which has an app protection policy applied. This setting tells us 3 things. First, we'll allow the transfer of and paste data from a policy managed app into other managed apps. Second, we will prevent the pasting of managed app data into unmanaged apps. And then finally, the with paste in portion of this setting ensures that unmanaged app data can be pasted into the managed app. The second setting we'll look at is restrict web content transfer with other apps, and it is configured with the value of Microsoft Edge. What this setting tells us is that when a work or school account, a managed account, taps on a web link, that web link must be transferred into a web browser that also has an app protection policy applied. In this case, Microsoft Edge. Let's look at our access requirements. Our access requirements in this policy indicate that the user must utilize a 4-digit simple PIN in order to access work or school account data. In addition, we allow biometrics. And after a period of inactivity, we will prompt the user to either utilize biometrics or enter the PIN again. And then finally, we have our conditional launch settings. In this case, we will block access in the event that the device is jailbroken or rooted, and we require a minimum operating system of 12.4.6 on iOS from a device condition perspective. And we can see our inactivity timers. We will wipe data if the app in question hasn't accessed the Intune service after 90 days, and will block access to the data if the app hasn't connected to the Intune service after 720 minutes. Now that we've reviewed the policy, let's see what the experience looks like from the end user perspective. Here we have Joanna's iPad, and we can see she has a number of the Microsoft Productivity apps installed. Let's launch Outlook. Here we can see that Joanna is prompted to enter her PIN, so she'll enter her PIN. And we can see that she has several messages in her inbox. But first, let's tap on the left-hand navigation to see that Joanna has a work account from her Lucerne company, and she has an Outlook.com account, so a personal account. If we go into her work account, we can see that Alex has sent her a message regarding the status of Project Northwind. Here we can see that Alex has asked for a status update and has included a web link. If we were to tap and select some of this information, we can see we have the option to copy. If I were to launch OneNote, we can see here that Joanna has a notebook for Project Northwind status updates, and she can paste the content from that message because she's pasting content from a managed app into another managed app. However, if Joanna were to attempt to paste into the iOS native Notes app, that data would be blocked. That data transfer cannot complete, and she's guided with information that tells her why she cannot paste that data. Likewise, even within Outlook, these type of paste controls are applicable. If Joanna were to attempt to paste this content into a new message from her personal account, she would also be blocked. Now let's look at the web links. So if we go into settings of Outlook, we can see that the default experience is to use Safari with web links. However, because we have an app protection policy applied that indicates that web links must be open in Edge if those web links originate from a managed account, Safari will not be used in this case. And as you can see, Edge is launched. And furthermore, the link is launched in Joanna's work account within Edge. And Joanna cannot, for example, take this web link, copy it, switch into her personal account, and transfer the web link either. Okay, so in conclusion, hopefully you now understand how you can protect Outlook data on your devices by leveraging threat defense partners or Microsoft Defender ATP to assign device risk, by ensuring Windows devices are registered in Azure Active Directory, enrolled in a unified endpoint management solution like Intune, and compliant, and ensuring that mobile apps utilize Intune app protection policies to protect the data on those mobile devices. Thank you for attending, and I hope you found this session valuable. If you have any questions, please don't hesitate in reaching out. And if you'd like to learn more, check out the rest of our content on mailbox protection with Microsoft 365. Thank you.